The period of sine and cosine is 2 pi. Let's expand graphically on what that means. If we start at an angle of, say, pi over 4, and then we go counterclockwise around the circle one time, we end up back at the same place, pi over 4. So pi over 4 plus 2 pi equals, looking over to the right here, 9 pi over 4. 2 pi is equivalent to 8 pi over 4, so pi over 4 plus 8 pi over 4 is 9 pi over 4. If we were to continue around the circle again, one more revolution, then we would again end up at the same place. By adding an additional 2 pi or 8 pi over 4, we're now at 17 pi over 4. Conversely, we could go clockwise around the circle in a negative direction, starting from pi over 4 in a negative direction, end up at the same place, and now we would be at pi over 4 minus 8 pi over 4, which is negative 7 pi over 4. If we went around the circle again, we would end up at negative 15 pi over 4. To look at this in another format, let's look up here where it says a sine of pi over 4 plus or minus 2 pi n. So if we start at angle pi over 4, and we either add or subtract 2 pi times the number of n revolutions, then the value of that trig function is going to be the same as sine of pi over 4. So there are infinitely many solutions based on the number of revolutions that we take. Put another way, the sine of pi over 4 and this equals the sine of 9 pi over 4 equals the sine of 17 pi over 4, or going the other way, the sine of pi over 4 equals the sine of negative 7 pi over 4, which equals the sine of negative 15 pi over 4. All of these functions have the same value. If, for example, we were taking the sine of any of these angles, we would get the same value, positive square root of 2 over 2. What this means in practical terms is that if you're given a problem with an angle that's greater than 2 pi or less than 0 radians, you can find a coterminal angle somewhere between 0 and 2 pi to solve that trig function. The answers of both angles will be the same because they're coterminal. In general terms, if we look at the top left corner, the sine of an angle theta plus or minus 2 pi times the number of n revolutions is going to be equal to just the sine of theta. Likewise, with cosine, since it also has a period of 2 pi, the cosine of an angle theta plus or minus 2 pi times the number of n revolutions will equal the cosine of theta. So remember, our goal is to find theta such that theta is between 0 and 2 pi if we're dealing with radians, or between 0 degrees and 360 degrees if we're dealing with degrees. Let's take a look at a couple of examples. So here we have the sine of 13 pi over 6. So in order to see whether that's outside of 0, between 0 and 2 pi, it's often easier to rewrite it as a mixed fraction. So 13 over 6 is equivalent to 2 and 1/6. In this case, 2 and 1/6 pi. So we know that we're 1/6 pi above 2 pi radians. So we should be able to subtract 2 pi and end up with 1/6 pi or pi over 6. So let's do that. We start with 13 pi over 6, subtract 2 pi. Using a common denominator of 6, we have 13 pi minus 12 pi over 6 equals pi over 6. So now, if we evaluate the sine of pi over 6, that will be equal to the sine of 13 pi over 6 because they're coterminal angles. And the sine of pi over 6 is 1/2. Next, we have the cosine of negative 7 pi over 2. Again, rewriting this as a mixed fraction, we can see that we have negative 3.5. Now, if we were to add 2 pi to that, we would still be at a negative 1.5 pi. So in order to have a positive angle between 0 and 2 pi radians, we're going to have to add 2 revolutions, or 2 times 2 pi units. So if we look at that down here, we have 7 pi over 2 negative, plus 2 times 2 pi, or 4 pi. Negative 7 pi over 2 plus 4 pi. And using a common denominator of 2, we have negative 7 pi over 2 plus 8 pi over 2 equals a positive pi over 2. And the cosine of pi over 2 is 0. Now go ahead and pause the video and try this problem on your own. We're given the cosine of 8 pi over 3, so we could rewrite this using a mixed fraction as a cosine of 2 and 2/3 pi. So if we subtract 2 pi from 8 pi over 3 minus 2 pi equals 8 pi over 3 minus 6 pi over 3, using a common denominator of 3, we're left with 2 pi over 3, which is what we would expect from our mixed fraction up here. Let's diagram this to help us see this problem a little bit more clearly. So draw a unit circle, and our coterminal angle we just found is 2 pi over 3, which would be approximately right here. So theta is here, and theta prime, our reference angle, would be the difference between the terminal side of the angle and our x-axis. We'll draw our right triangle, and now we need to find our reference angle. So our reference angle is going to be pi minus 2 pi over 3, which equals, using a common denominator of 3 pi over 3 minus 2 pi over 3 equals pi over 3. So our reference angle is pi over 3, or in degrees, that's 60 degrees. Now we can go ahead and label our triangle. So since our reference angle, theta prime, is 60 degrees, we know the opposite side of 60 degrees is the square root of 3 over 2. And since we're in quadrant 2, it's positive because it's a y value. The adjacent side of theta prime is 1/2. And since we're in quadrant 2, the x value is negative. Now we can go ahead and evaluate our trigonometric function. Oh, and by the way, the hypotenuse, of course, is 1. So the cosine of 8 pi over 3 is equivalent to the cosine of 2 pi over 3. And using our reference angle pi over 3 to evaluate that, then the cosine of our reference angle is the adjacent side, negative 1/2, over the hypotenuse, 1. So the cosine of 8 pi over 3 equals negative 1/2 over 1, which equals negative 1/2.